Okay, so today is September 12th. This is like a little warm-up lecture for me. I think this will only be like 5 minutes or so. Resume around slide 25 of my topic 2 contents, which are these here. So if we go to slide 25, oops, well, that was interesting. 125. Okay, as what we're talking about. This unexpected division result. It's unexpected because in C++ and in other languages, I think Java, uh, integer division occurs where we might be expecting the number 2.5 to appear here. Instead, the number 2 appears when we run this program. Yeah, the number 2, so not 2.5, and it also prints hello world on the line down below. Again, what's the purpose of this \n? If we omit the \n, we will see 2 and then hello world printed on the same line. So one way to get what we are generally expecting is to what is sometimes called float promotion, promoting that value to a float. So now if we perform this operation, we see the result that we expect. Okay. Just scroll under my slide here. Yeah, so really simply, that's a way to get what we probably expect. If we were to declare an integer and call it the dividend, not to be confused with stocks, like stock dividends on Wall Street or something, and we set up a variable called divisor, and we say it's equal to 2, and we replace these values with variables, which is pretty typical, useful in certain circumstances. These are 2 integers, so we will be performing integer division on them. If we change them to floats or doubles, doubles have more precision than floats. That's the difference. Floats are called floats because the decimal point here in this number could be represented as 0.5 times 10 to the first power, or equivalently, it could be represented as 50 times 10 to the negative 1 power. And this may be difficult to understand if you don't have any familiarity with what is called this IEEE standard. But let's just imagine this decimal point floating along to various positions, and this is why we call a float a float. That's not a perfect explanation, but it's just a start, and we probably don't want to get too deep into it. 2.5 is what we see. Okay. All right. We do have to be careful of integer division when we write programs. In certain languages, in Python, that would get interpreted just as a floating point division. So to remark on limited precision, if we take an example that I have on my slides, we say 34.5 divided by 6.5, and we get this big long number with, like 12 points after 12 values after the decimal. If we do the same thing in C++, let's see what we get. We get the output 5.300769. And so evidently there's a certain amount of, there's a default precision that Cout uses whenever it prints. It only prints a certain number of digits after the decimal place, which is not a particularly radical concept. All right. So I had this this program, which is this assignment, this lab, which is converting inches to feet and inches, and here it is right there. So 49 inches is equal to 4 feet and 1 inch. And this is a fairly nice demo of the mod operator. So if we say int total inches, and why am I saying total? It might become apparent in a minute here. We could say int equivalent feet. And that is going to be equal to 49 integer divided by 12 because there are 12 inches in a foot. And remaining inches, I'll call this is equal to 49 mod 12, and that's what that symbol means. Now we could say total inches equal, let's give some text here. No. Text here, I mean, inches is equal to, and we can come down a line if we like, maybe to make this line of code more readable. So we say equivalent feet. So we'll say like 49 inches is equal to 4 feet because that's what this evaluates to. It does not evaluate to 4 point something, like 4.1 or 4.08, I think. 4.08 something. That's floating point division, and both of these are integers, or this is an integer, and also the 12 right there is an integer, of course. There is no 0.0 after it, or 0.1, because there aren't 12.1 inches in a foot. Okay, but just to run this and show an example of, I've got 5 submissions so far. So most students in this class this semester haven't submitted this yet. Okay, let's add the variable name, which is equivalent feet. Not, I think not the most clear variable name, but oh, I already put that. Excuse me. So I'm going to say it's equal to 4 feet, and so a certain number of remaining inches, which should be 1 in this case. This operation could be regarded as the remainder operator, if you would like to call it that. No, that's a decent name for it. We usually say mod, as in MOD, mod 49, mod 12. 4 feet and 1 inch, and we could put like ES here if we wanted to be grammatically correct, which is always a nice idea. So if we run this program, we see 49 feet is equal to 4 feet and 1 inch, parentheses ES. Okay. So if we, what I should have done here actually, in the interest of not having to type, in the interest of a better program in a way, is just replace this with the variable name. And now I could change it here, and I won't have to change the 49 to an 81 here. And that is one of the purposes of variables. I hope that's obvious. 81 inches. Okay. So probably very few people are, I mean, we know that very few people are 6 feet and 9 inches, but maybe we're talking about a piece of wood that we're cutting to build a house. And if we pass in negative values, just to play with this, you can set this equal to a negative number. We see what happens, and we get -6 feet, -9 inches. So seems a bit unreasonable, but the intention here is to play. But if you set this equal to, a float, -1, if you declare the data type as a float and you say like 81.5 inches, then the mod operator is actually not defined for a floating point type. So it says here the expression must be an integer. Okay. All right. That's a decent little exposure to, that is all I'm wanting for the converting inches to feet and inches lab. So I'll stop here.